ஓகே, லைவ் வந்தாச்சு. ஓகே, எதுக்கு இந்த லைவ் அப்படின்னா, சும்மா எனக்கு போர் அடிக்குது, அதனால லைவ் போடுறேன். அப்படி சொல்ல மாட்டேன். இன்றைக்கி நம்ம வந்து ஹஃப்னு சொல்லி ஒரு லோ லெவல் லாங்குவேஜ் பற்றி பேச போகிறோம். ஸோ இங்கே நிறைய பேர் வந்து சாலிடிட்டி பற்றி கேள்விப்பட்டிருப்பீங்க, ரைட்? Maybe I can show you the statistics. Yeah, as of now, in the blockchain domain, the solidity is the language that dominates. For example, DeFi Llama. So இதுக்குள்ளே போயிட்டு, if you go for, I think ரொம்ப நாள் ஆச்சு நான் இதை EVM, Ethereum is dominating the space. See, around $69.185 billion are being logged in Ethereum blockchain. And Solidity is the primary smart contract language which is used in the Ethereum chain. So அதனால் it's very important. Being a blockchain developer, you should know how Solidity smart contracts works. So at the end, Solidity is a EVM based programming language. What is EVM? EVM stands for Ethereum Virtual Machine. ஸோ நீங்கள் ஜாவா படிச்சிருந்தீங்கன்னா உங்களுக்கு தெரியும் JVM, Java Virtual Machine. So the code that runs on specific virtual machine, right? In our case, the Solidity is one that runs on Ethereum Virtual Machine. It's not a physical device, it's an implementation. So if you are running an Ethereum node, so by default you are running an EVM compatible system where you can run the Solidity contract, right? So likewise, இன்றைக்கி நம்ம பார்க்க போகிற லாங்குவேஜ் பார்த்திங்கன்னா ஹஃப் ஸ்மார்ட் கான்ட்ராக்ட். What is Huff? Huff is a low level EVM compatible Solidity smart contract like Solidity இருக்க மாதிரி ஹஃப்ங்கிறது it's a low level programming language to develop smart contracts on Ethereum, right? Introduction. Welcome to our beginner tutorial for smart contract developers interested in learning more about the EVM. This tutorial aims towards the developers who are already familiar with smart contracts and have some experience programming in smart contracts. So you need some prerequisite before getting into Huff programming language. You definitely need some knowledge about the smart contracts and also some programming experience in Solidity and Viper. um, just give me a second. சொல்லி ஒரு லோ லெவல் லாங்குவேஜ் நான் மட்டும்தான் லைவ் பார்க்குறேன். கே கேட்பீங்க லைக் 2 மணி 1 மணி ஆகுது, இந்த மணிக்கு யார் பேர் யாரா வருவாங்க அப்படின்னு எனக்கு இப்போ தானே பண்ண தோணுது. ஓகே, in this tutorial we will cover the basics of EVM, Ethereum Virtual Machines. நான் ஏன் வந்து ஹஃப்பை வந்து லேர்ன் பண்ணுங்கன்னு சொல்கிறேன்னா, நீங்கள் ஹஃப் லேர்ன் பண்ணாவே ஆப்கோட்ஸ், ஹவ் ஆப்கோட் ஒர்க்ஸ். ஃபார் எக்ஸாம்பிள், let's consider popular smart contracts. Maybe let's consider wrapped ETH, right? Wrapped Ether, Ether scan. So wrapped Ether it's a ERC20 version of Ethereum, right? So it is an ERC20 it follows ERC20 standard. So if I go inside the contracts, at the end of the day, this contract is nothing but an opcode. So this is the contract creation code, this is the contract's bytecode. So இதுதான் வந்து opcodes சொல்லுவாங்க. Every 2 characters in this bytecode is an opcode. So if you want to understand this, you need to learn how Huff works, right? Over the time நீங்கள் ஹஃப்பில் ப்ரோக்ராம் பண்ணிகிட்டே இருக்கிறப்போ you will get a familiarity. ஓகே, இதனால தான் இந்த ஆப்கோட் இங்கே யூஸ் பண்ணுறோம். ஸோ இதனால தான் இது மெமரியில் இருக்குது, இதனால தான் இது ஸ்டாக்கில் இருக்குது, இதனால தான் இது ஸ்டோரேஜில் இருக்குது. ஸோ யூ வில் கம் டு நோ ஹவு த EVM ஒர்க்ஸ் by learning how to code in Huff, right? So the basics of writing assembly in Huff. Hello world in assembly, simple storage. இதுதான் நம்ம இன்றைக்கி பார்க்க போகிறோம், simple storage in assembly. So we're going to have a state variable, and there are 2 important functions, set number and get number. So we're going to set a number, we're going to get a number. First is Solidity எப்படி இது ஒர்க் ஆகுதுன்னு பார்க்கலாம். Then we will try to replicate the same code on the Huff programming language. So I have already developed the Huff code for simple storage in assembly. Now I will explain you how it works, right? So if I go back to the contract, is it possible to increase my voice? ஃபுல்லாக தான் இருக்குது. ஓகே, அதுக்கு முன்னாடி லைக் I want to thank Siphon Updraft. So I'm using their code base. I want to give some credits to them. Thank you, Siphon. வேறு ஒருத்தராச்சும் லைவுக்கு வரலாம்ல. ஓகே, so in the Horse store, this is a contract. So as I said before, so there are 2 functions. The function to update this U/56 variable, number of horses. It takes a parameter of new number of horses and it sets to the number of horses. The update horse number is the function name. It is an external function, and there is one more function. So by default it is an internal. So இப்படி தான் இருக்கும். Like if you are not implicitly mentioning, by default if you are not mentioning, it is an internal variable, right? So you need a public function to get back the number. So in our case we are creating a number, we are creating a function called read number of horses, which is an external view function. So why is it view? So we're just going to read the state, we are not going to update the state. If you are not reading the state also, if you are not writing and reading the state, you can define it as a pure PURE. But இப்போ பண்ணப்போ it may show error because you are reading the state. The function declared is as pure, but this expression potentially reads from the environment or the state. ஸோ அதனால் மூடிட்டு வியூ கொடுறா அப்படின்னு சொல்லுது. ஓகே ஃபைன் கொடுத்தாச்சு. ஸோ இட் ரிட்டர்ன்ஸ் அஸ் த நம்பர் ஆஃப் ஹார்சஸ். Very simple contract. So we have a state variable which is of type u256, and we have two functions, update horse number and read number of horses. Update horse number updates the number of horses. Read number of horses returns the value in the un256, right? இப்போ நம்ம என்ன பண்ணலாம்னா இதை காப்பி பண்ணி ரீமிக்ஸில் ட்ரான்சாக்ஷன் இனிஷியேட் பண்ணலாம். இனிஷியேட் பண்ணிவிட்டு இதை எப்படி ஹஃப்பாக ரீப்ளேஸ் பண்ணலாம், இந்த சால்டேட்டிக் கான்ட்ராக்டை எப்படி ஹஃப்பில் எழுதலாம், ஹஃப்பில் எப்படி ரீரைட் பண்ணலான்னு பார்க்கலாம். ஓகே, வெரி இன்ட்ரெஸ்டிங் அப்படின்னு நானே சொல்லிக்க வேண்டியதான். ரீமிக்ஸ் எத்தீரியம். இப்போல்லாம் நான் ரீமிக்ஸ்னு போட்டாவே போல்கோட் அடுத்து தான் வருது பாருங்களேன். போல்கோட் அடுத்து தான் வருது. நான் நிறைய டைம் வந்து கன்ஃபியூஸ் ஆகிட்டேன். ஸோ லுக் ஃபார் Ethereum ID, not for the Polkadot. Elena, I think you can also provide the URL http://remix.ethereum.io. அப்படியா? http://remix.ethereum.org. So this is the correct really I'm not getting it. Here remix Ethereum ID, remix.ethereum.org. ஸோ லைவ் போட்டு 10 minutes ஆச்சு. எனி கமெண்ட்ஸ்? யூனோ வாட், நான் ஏன் லைவ் போடுறேன்னு தெரியுமா? whenever I feel lonely I just யூடியூப்பில் லைவ் போட்டுறேன். சரி, நம்ம இங்கே வந்து சும்மா இருக்கிறதுக்கு ஏதாச்சும் சொல்லலாம்ல. ஆச்சு போய் அதனால தான் நான் லைவ் போடுறேன். அதே மாதிரி இன்னொரு விஷயம் இருக்குது, நான் அப்புறம் சொல்கிறேன். ஓகே, கம்மிங் பேக், கான்ட்ராக்ட் storage.sol அந்த கான்ட்ராக்டை ரீப்ளேஸ் பண்ணிடலாம். ஐ டோன்ட் வாண்ட் டு ஆஸ்க் ரீமிக்ஸே. First thing is we need to select a compiler. So compiler 0.8.31. Okay, fine, let it be. I'm going to compile. There is a shortcut, Control S கொடுத்தீங்கன்னா Controller Command S. Okay, both will compile it. So compile பண்ணுறதுக்கப்புறம் you will get a green check mark. Before deploying it, check whether it compiles properly. If you have any syntax error, it may revert, so try to solve it. Next, deploy tab. So we're going to deploy on Remix VM. We are not going to use any gas or testnet. Okay, I'm going to deploy it. So it does not take any input parameters inside the constructor. We don't have a constructor. Initially the number of houses is going to be 0. Let's verify it. So I'm going to deploy it. Yeah, it's been deployed. Fine, it's been deployed. I don't want the explanation for the contract. Here you can find the contract, deployed contract. Let me zoom in a bit. Deployed contracts, horse store is at this contract address. The balance of this contract is 0 as it's not a payable contract. We are not going to handle any of the Ethereum payments over here. And as I said before, we have two functions, update horses and read number of horses. Initially the value should be what? Initially the value should be 0. Let me click on this. We have 0. Now I'm going to update the number of horses. Maybe let's go for 96. Okay, 96. 96 is my favorite movie. So I'm going to update the number of horses. You can see the transaction has been gone through over here. Now let's read whether the number of horses has been updated or not. If I click on this read number of horses, it should return us 96. It's a 96. And one more thing, like, have you noted, like, we have two colors, the blue as well as orange. You know why? Fun fact. So if it is an orange, it's going to spend gas. We're going to send a real transaction to update the state. It's a write function. So whereas if it is a view function, or we are not going to update the state of the blockchain, or we're just going to read or view the state of the blockchain, then it's going to be blue. Interesting, Pusarga. Alright. Okay, this is very simple contract. Now we will try to replicate the same contract using Huff. Huff is a low-level programming language used specifically for developing smart contracts on EVM, Ethereum Virtual Machine. So it's a domain-specific language. It's a low-level language, right? Let's see how it works. I have not installed the Huff extension. Let me install it. Huff, Huff. Let me install the syntax highlighting. Hopefully it looks good. Command Shift P and then reload window. Here you can find the changes. Now it looks good, right? Okay, again I want to thank Siphon Update for the code. So mostly in Huff contracts we deal with macros rather than functions. They both are different. As of now you can consider macro as a function, right? So how do you define a function or a macro in Huff? So let me zoom in a bit. Using a syntax called #define macro, the name of the macro, equal to, it takes 0, returns 0. Let me explain you what is takes 0 and returns 0. Basically EVM is a stack based machine. Okay, everything acts as a stack. What is meant by stack? Let's go for whiteboard. You know the stack of pancakes or stack of books, stack of plates. I think the first in is lost out. Yeah, you need to extract all and then you will get back the first thing that you have put into it. Let's say I don't have a digital pen, so I'm just drawing using my touchpad, so apologies for my drawing. So let's say we have a stack, okay, and I can push elements into stack. I can pull the elements out of the stack, right? So it's like a stack of books. Fine. So here in our code base, so there is takes 0 and return 0, which means like this function is going to take 0 elements from the stack and it's going to return 0 elements into the stack, right? So it's an input and this is an output. So it's going to take 0 out of the stack and it's going to put 0 elements into the stack. You got it? Fine. So that's what this takes 0 and returns 0. So mostly you don't use it over here, but if you are implementing something like ERC 721 or ERC 20 standards, then sometimes when you want to reuse a functionality, you implement this takes and returns value. Fine. Okay, this is very important. The first stage, so when we are using the remix IDE, When we are calling this function update horse number, we are sending an input value, right? We are sending an input. Let me call with some other number, maybe 100. When I call this update number of horses, we are making a transaction. If I got into this transaction, I could find the input parameters. Where is the input parameter? uh, Decode output, raw logs, transaction status. Decoded input. So this is the input, I think. Let me copy it. Let me paste it over here. I have copied it, right? Copied. Maybe I can go to the text format. Um, Actually, usually you send a bunch of opcodes as an input whenever you're calling a function on a blockchain, right? So this bunch of um, bytes are known as opcodes. So when you send this input data to a contract that's on the blockchain, there should be some module to decode the input data and just delegate the corresponding input to a corresponding function, right? So this is called as um, what is it called? It is called as function dispatching. Fine, you're going to dispatch the input data to a specific function. You're going to route the input data to a specific function. Okay, how are we doing this? So there is a 0x00 call data load, 0xEO, SHR. What does it mean? Let me explain. This call data load is an opcode. So there is a website called evm.codes. So if I go and search for the call data load, it takes two things. The stack input, as I said, EVM is a stack based machine. It takes the input and it outputs from the stack, outputs to the stack. It takes the input from the stack and it output to the stack. So here the input is the bytes offset and then the output is 32 bytes value starting from the given offset of the call data. So this call data load is an opcode that gives us the call data, okay, that's been forwarded in the transaction starting from the bytes offset of the input, the I. Here the I is 0, which means like I don't want any offset. Start from the first byte all the way to the 32nd byte. Give me the 32 bytes of the call data. Okay, this is going to return us the 32 bytes of the call data. And from this call data, the first 4 bytes is going to be the function selector. Okay, so I have to remove all the other bytes from the call data to get only the function selector. Okay, let's go for the calculation. Let's say this call data loads 32 bytes, right? Among these 32 bytes, only the first 4 bytes is going to be the function selector. So this function selector is going to be used for delegating the input data. Okay, so let me reduce the 4 from here. So what is the result? 28. Okay, so and one more thing, this left switch, right, this right switch takes the input as bits, not bytes, bits. 1 byte is equal to 8 bits. So if I go for this SHR means shift the bytes towards the least significant one. The byte moves before the first one are descended. Okay, let me explain you more deeply. So it takes two things as an input from the stack. What are the two things? The value, the 32 bytes to shift, and what are the next things? The shift. Here, note it down. Number of bits, not bytes, bits. 1 byte is equal to 8 bits to shift to the right, as it is a right switch. What is the output it's going to produce to the input to the stack? It's going to be the value after shifting this value this number of times, right? You got it? Let me explain you through the code. So the first 4 bytes is very important. I'm going to right switch all other 28 bytes, okay, as we have to import bits. 1 byte is equal to 8 bits. 28 byte is going to be how much? 224, right? So what is the hexa value of 224? OXEU, right? I think there is a cast command. So if you go into the foundry has a cast command, dash dash 2 base. I think dash dash 2 base, and you have to input the 224. I think, yeah, 224 hex, which returns us the hexa value of the decimal 224, 0x EO, 0x EO. So what does it mean? I'm going to get the call data, the first 32 bytes of the call data, and I'm going to right shift the last 28 bytes. And what is going to be in the stack? The first 4 bytes of the call data, which is going to be the function selector. Fine. Okay. Now that the stack contains the function selector, now we have to check if this function selector matches any one of the function selector that's been defined in the contract. So this underscore func sig is a special syntax for the Huff that returns us the function selector of the update horse number. Where this update horse number is defined inside the interface. How to define the interface? It's very similar to the ABI part. Define function, name of the function, the parameter that it takes. We just want to mention the data type. So as it is a non-view function, we have to make it as non-payable. So this is specific to Huff. So when you have to define an interface for a function does not view, which is not a view function, then you have to mention the non-payable parameter. Got it? Okay. So returns nothing. Likewise, we are also defining the read number of horses function. So as it is a view function, we have to just mention a view function. No need to mention the non-payable. Fine, we are going to define this interface, and from this interface, using the underscore sig function, we're going to generate a selector, right? So if I want, I can also provide you a cast command that returns the selector from the signature. So here cast sig update horse and pass the parameter data type. This should return us the function selector for this function. So this is the function selector. So we're going to check if this function selector matches the one that's in the stack that comes as a call data. Correct? So if this matches, then we are going to jump to this update jump program counter. Very important, program counter. If the function selector that's in the stack matches the function selector of this update horse number, we're going to jump to the update jump destination, which contains a macro set number of horses, which we have defined over here. Let's go through it. So hopefully you understand. I don't think so we need to pony here. because we don't have any other functions, right? Why do we need over here? We don't need it. Okay, fine. You may have a question, why do we need this dupe one? So right now, once maybe let's say the function call, the call data is for read number of horses, not for the update number of horses. So which means once this line ends executing, in the stack we don't have any data, but we need to have the function selector to compare with the read number of horses. So what do you mean? Should I rerun this? Is there any other way to make it more efficient? Yes, there are ways. How can we do it? Instead of rerunning this, I'm going to duplicate the function selector once after calculating it. So which means even though this line executes and the function selector does not matches, still the stack contains the function selector that we can compare with read number of horses. Got it? That's the purpose of dupe one. Fine. So if the read number of horses matches the stack's function selector, it's going to jump to the read jump. Again, we have defined a get number of horses macro. So we have two important macro that we have to go through. Once after going through it, maybe what can we do is maybe we can run to the CVM playground. Okay, we can run the program and we can see how the Huff contract works. I don't know, for some reason I could not find the input data. Usually the input data is visible over here, but right now I could not. I find it very hard to find it. 100. Maybe I can input one so that I can find it. If I make a transaction. Here is the data. Data. Where is it? Raw logs, transaction. So I could see the data over here, but I could not copy it for some reason. Maybe I should debug it. Oh, these are the hop codes that we were discussing. Function state. But here is the data. This is the data that's very important. But for some reasons I could not get the data. This is the decoded version of the input. Raw logs. Maybe raw logs may contain. I'm not sure. No, that's not the thing. I don't know, for some reason I could not get the input for this function call. But here you can see under the data. Where is this? Under the data. Here. Under the data, this is the function input. So you start with the function selector and finally you encode with 32 bytes of input that you are passing. Maybe we can test it for read number of horses, right? Yeah, that's a good idea. Alright, let's discuss about other two macros. The macro to set the number of horses and get number of horses. This is going to be trivially easy. Set number of horses, again it takes 0 from the stack and it puts 0 to the stack. It returns 0 to the stack. What is this OX04 call data? Okay, again. So What is a call data? A call data is a combination of two things. One is the input data, other thing is the function selector. So right now we need the input data to store the value to the blockchain state. So for that, what we are going to do, we're going to remove the first 4 bytes, which is not needed, which is a signature. I mean, the selector, which we generate from the signature, which is not needed, right? Now we need to only consider the last 28 bytes, which contains the input data. Okay. So what should I do? I have to increase the bytes offset for the call data load input. So this what happens is it's going to um, start with the fifth byte and it's going to ignore the first 4 bytes. Okay, and then here at this stage inside the stack we have the value, and this is a specific to Huff. So it returns the free storage pointer where we can store the input. So this is how you load the storage pointer to the stack. So now we have the pointer and then the value. Then we are going to call the store opcode. What does store do? It's going to store this value to this pointer, and we're going to stop. Stop is a it's very similar to the return. It's like, okay, the transaction is done, the execution is over, now we have to stop it, or else it may execute, it may start execute this definition macro. Fine. So this is how you store a value to the blockchain in Huff. Right now we will see how to read the state from the blockchain using this get number of horses macro. Load the value from the storage. uh, so we have to do two things. One, we have to load the value from the storage, and we have to put it onto the memory before returning it. You can't directly return from the storage. Okay, that's a bit difficult part when it comes to returning a value. It can't be returned directly from the storage, it should be returned from the memory. So now we are going to load it. Right now the value is in the stack, we have to put it in the memory. So for that we are using the mstore. Store means from storage load it, mstore means to the memory store it, right? Store it from the bytes offset 0x00. Its size is going to be 20 bytes. 0x20, which means 32 bytes. Then this is the return value. So starting from 0x00 bytes offset all the way to 32 bytes, which is of 0x20 in hex, return all the value which has been stored in the memory. Fine. So this is how you read the value from the state using the Huff programming language. Now what we are trying to do is, I'm going to copy this and go back to the EVM codes. It's already been 37 minutes still we are since we are been live, so we'll complete it soon. So if I go over here, if I go and paste the contract, and then so this is not a Yule, this is going to be, oh, there's no way to run. Is there a way to run the Huff online? Huff online compiler. Compile Huff with Huff compiler. Maybe I should has to install it. Huffc. I need to install the Huffc. Maybe I will do it. Huffc, name of the contract, bytecode will return as the bytecode. What is F3? F3 is the return. Let me check. Go to opcodes. Command F, Command B. F3 is the return, yeah. Fine. Go back over here. Go to, how do I download it? Getting started. Install Huff. This is the bash curl command. I'm going to run it in my terminal. Let me paste it over here. Oh, is it that easy? I'm going to simply, before that we have to source the shell path. Once after sourcing it, I'm going to run Huff up. This is going to update it. Once downloading it, we will generate the bytecode. We will paste this mnemonic to the um, Huff playground. Yeah, I think it has been installed. Now it's time to run. What was the command? Huffc. What was the command here? Huffc name of the file dash bytecode. So Huffc, are we in the right directory? Do we need to mention the directory? Maybe if I go to Mac, do we have the command for the Huff? Oh, we have it. It stores in a text file. That's pretty easy. We'll do it. Or else we can do the manual Huffc. I have to pass the path to the Huff file, and I need to do dash bytes. What was the command? Bytecode. This should return the bytecode. Oh, why Huffc is not available? Maybe I can write Huff. Use make Huff. It seems like Huff is not being installed. Maybe I will install it over here. Go to getting started, install Huff. This was the command, if I'm right. Source the shell path, and then Huff up. Huffc dash version. Yeah, the Huffc is now available. Maybe I can run /src / hotstore v1. Should I want to pass this? Yes, hotstore capital V1 / dash bytecode. Remove this, paste this. Okay, this is the bytecode. I'm going to copy this, go back to playground. Where is the playground? Home. It's in the evm.code playground. Paste this mnemonic bytecode mnemonic F3. I don't need this. I'm going to run unknown mnemonic bytecode. Run. Maybe if I paste all, never run it. return from here from here the runtime code starts. Here you can see push 0, which is same as if I go to .huff 0 call data 0xevo shr 0 call data 0xevo shr. Right now we should have uh, what should we have on the stack? We should have the call data after removing the input part, just the function selector, and we'll go to dupe one, push the call data function selector for the update. We're going to check if it is equal, and we're going to push 001a. This is going to be the program counter. If it matches, we're going to jump. Where is 001a? 001a. So if it is matches, or else we're going to input this. This is the function selector for read number of horses. Fine. If it matches, then we're going to jump to 21. So this is the program counter destination. And here comes so this should be 230x1a. So let me go over to here, cast to base deck 26. Alright, so this is the jump destination for update. As you can see, so this is going to be the offset, call data load, push 0, push 0. So push 0 is the opcode for adding 0 to the stack. So this is the push 0. So pointer, a store, and then stop. So this is the jump destination for read number of horses, load it from the state, push it to the memory, return it to the output. Fine. Now what we are doing is we will try to read the state of a horse, number of horses. So this is the function selector for the read number of horses. I will paste it in the call data. Now I will try step by step. Are we ready, guys? Run should be x with 2 characters, 0x. Okay, I'm going to iterate to 9th one. Where are we here? Is it done? Is it done or what? What is the invalid opcode? So let me open it and maybe I can duplicate this. Duplicate tab. Opcodes invalid. FE is the invalid. Let me copy this. FE. So I'm going to remove all those things. jump destination. I don't know, for some reason I'm getting invalid without running this. Alright, let me run again. Step, steps, step, step, call, code copy, return size, return. So here is where the code starts. The code starts and it just ends like that. Uh, so as you can see, the program runs. For some reason I'm just getting some issues in this EVM code. Storage. Function dispatching. Test Huff with Foundry. Oh, Foundry deploy use பண்ணலாமா? Okay. So Huff language, the Huff.sh, Huff documentation has lot of details. You can go through it. But that's the end. It's been a hour. So in the contract we have seen in Huff how to replicate the simple storage contract in Huff. Maybe in next videos I will try to implement using Foundry for deploying this and getting the bytecode or the runtime code. Yeah, but definitely I'm sure like there is a command which just returns the runtime code. We'll find that and we'll let you know. I think it's time to end the class. End the live. You know what? I don't feel like ending this live. I don't know why. I don't know why. I don't know. Really, I don't know. Should I want to end the call? End the live, or should I be in the live? Actually, live le yaru illa. Still, I feel like maybe what else we can learn? What else we can learn? What else you can learn? I don't know, like I feel like after 1:32 is the right time for live, but I'm sure like no one will be available at that time. I feel comfortable at that time. I do feel sleepy right now. அதான் சொல்கிற மாதிரி நெக்ஸ்ட் கிளாஸில் எப்படி வந்து ஹஃப் டிப்ளாயர் யூஸ் பண்ணி ஃபவுண்ட்ரியில் ஹஃப் கான்ட்ராக்ட்ஸை டிப்ளாய் பண்ணி டெஸ்ட் பண்ணுறது நெக்ஸ்ட் வீடியோவில் பார்க்கலாம். இஃப் யூ ஆர் ரியலி இன்ட்ரெஸ்டட், மேபி இந்த வீடியோ 10 லைக்ஸ் வாங்கிச்சுன்னா அடுத்த வீடியோ அது பண்ணலாம். ஓகேவா? ஓகே, வாட் இஸ் த சம்மரி அட் தி எண்ட்? வாட் வி ஹவ் லேர்ன்ட், என்ன லேர்ன் பண்ணோம்? ஃபர்ஸ்ட் இந்த கான்ட்ராக்டை நான் எக்ஸ்பிளைன் பண்ணேன். அப்புறம் ஆப்கோட்ஸ்னால் என்னன்னு பார்த்தோம். அதுக்கப்புறம் வி வென்ட் த்ரூ திஸ் Huff contract, what is macro, how do we function dispatching, how to define a function or a macro in Huff, how to get the input data, how to store the input data, how to retrieve the input data, how to load it on the storage, how to load it on the memory, how to return to the user. இதெல்லாமே we have seen today. Wait a minute, it does not produce us anything, that's fine. And then we just took this and then we installed this Huff compiler, which returns us the bytecode, opcode. We copied this and then went through the evm.code playground. We pasted the mnemonics and we tried executing it step by step. So the main thing that you have to take a note is how to dispatch a function selector from the call data, and how to store it on the memory, how to load it on the stack, how to load it on the storage, how to return to the user. These are the few things you should understand when writing the Huff code. So again, thank you to Siphon for letting me use their code. Thank you so much. Should I want to end? Maybe I should end. Alright, I'm going to end the live. Thank you for watching. I'm damn sure like no one is going to watch this. இருக்க பிரச்சனை இல்லை, இதை வேறு பார்ப்பாங்க. Okay guys, it's time to go and sleep. Thank you for watching. பிடிச்சிருந்ததுன்னா தட்டி விடுங்க, சப்ஸ்கிரைப் பட்டனை தட்டி விடுங்க. அப்புறம் எத்தனை பேர் பார்க்குறாங்கன்னு பார்க்கலாம். One watching bro, one watching. You know what? Who is that one? That's me. I'm the one. சும்மா சொல்ல கிடையாதுப்பா. 100 சப்ஸ்கிரைபர் இருந்துச்சு நான் பார்க்குறப்போ, இப்போ 120 இருக்குது. நல்ல ப்ரோக்ரஸ் தானே. இது 100வது வீடியோடா, நம்மளோட 100வது வீடியோ, 100th வீடியோ. அதனால தான் வந்து இந்த லைவோட இமேஜை வந்து எனக்கு பிடிச்ச கேரக்டர் ஒன்று போட்டிருக்கேன். அந்த கேரக்டர் யாருன்னு தெரிஞ்சால் கமெண்ட் பண்ணுங்கள். இந்த கேரக்டர் பேர் நான் சொல்ல மாட்டேன், பட் நீங்கள் கமெண்ட் பண்ணுங்கள். அது வந்து ஒரு பாப்புலரான ஒரு கேரக்டர், ஒரு ஃபீமேல் கேரக்டர் தான். சைபர் பங்க்கில் வரும். காப்பி ஸ்ட்ரைக் இது கொடுத்துடாதீங்கப்பா. Alright, thank you for watching. See you on the next video. Until then, Balamurugan signing off.